my name is Joseph Wolfenden, and today we're going to be learning about 2D rigid body equilibrium. So the first thing is all the forces have to sum up to 0. The next is that the body is in a 2D plane. Here we have the forces of x, y, and the moment about the origin point, or whichever point we decide. All of those have to equal to 0. So for f of x, if we have 500 newtons going towards the right direction, the force going towards the left direction also has to be 500 newtons. Same thing for the forces in the y direction. If it's 500 newtons going down, then the force upwards also has to be 500 newtons. Right here, for the moment about point A, we have 100 newtons going downward over the course of 2 meters. So we do 100 newtons times the distance of 2, and that gives us 200 newtons per meter. And that's about the A. So first we're going to look at a force body diagram of the reactions about A and B. At A, we have a force going to the right because of the moment right here, 600 newtons. One force is going to be to the right, and the reaction is going to be to the left. We also have a force going upwards at A, so the reaction at A is going to be going downwards. All those forces have to equal up to 0. On B, we're going to have one force going to the left, pushing onto B, so the force at B has to be equal to that force going in the right direction. And here's the example problem. So first thing we're going to want to do is find the moment about point A. So first thing we know, we have a 600 pound-foot moment right here because it tells us in the problem. So we're going to add that in right here. And then we're going to add the rest of our forces. So right here at A, we have an arrow going down with a 3-4-5 angle. And the force we want is the one going straight down in the y direction. So we're going to add 500 pounds times 4/5, so we can get the y direction, and then multiply that by 5 so we get the moment. And then the last force we have is the force of B. B is providing an upward force, so we're going to do minus By times 10. That's the 10 feet right here from A to B. Once we calculate all that out, we get the By is equal to 260 pounds. The next thing we're going to do is find the sum of the forces in the y direction. So for y, this is going to equal 0. And then we have AY. Right here, we have the y going the upward direction, plus By, which we already solved for right here. And then we have the minus 500 times 4/5. When we're finding these forces, we don't have to get the moment because this is just all the forces in the y direction. So we have AY is equal to 400 pounds from this 500 right here minus By. And we know By is equal to 260. So that leaves us with 400 minus 260, and AY is equal to 140 pounds. in the last part of our equation, to find AX, or AY, AX, we're going to find the forces in the X direction. So we have negative AX right here, going this way, plus the 500, and this time it's going to be multiplied by 3/5, since we're finding it in the X direction, and that is equal to 0. So AX is equal to 300 pounds. So we found the forces at A and the forces at B using the moment and the force we have right here. And for the last real-world example, right here in the wall, there's a nail, and if we take this hammer and put it on the nail, like so, you can see that it stays. When you apply a force here, it still doesn't move because it's in equilibrium. So the force going down here, and the nail is providing an opposite force, as well as the force from the wall and the hammerhead.